Imagine you're playing a game where your job is to guess the next word in a sentence. If I say, the cat sat on the, you'd probably shout mat. If I say, peanut butter and, you'd guess jelly. If I say, once upon a, you'd say time. A large language model is like the world champion at this game. It is practiced by reading millions of books, stories, and conversations, so it's unbelievably good at guessing what word should come next. It doesn't stop after one guess. It keeps guessing word after word super fast until you get a whole sentence, a whole story, even a whole explanation to your question. But what really happens inside an LLM? Let's break it down, and you'll never see AI the same way again. Large language models are an obvious topic in any AI interview prep. If you're still using old FAANG prep guides, you're already losing ground. The rules have changed, and this free AI playbook shows you what's really being tested in modern FAANG interviews. Insider strategies, hidden evaluation matrix, a 90-day mastery plan, the exact playbook successful candidates are using right now. Everyone's grabbing it. Don't be the one left behind. Link in description. What exactly is an LLM? By definition, LLMs are AI systems which are trained on a huge corpus of data. So what I mean by a huge corpus of data is you can think of a good chunk of the internet is what is used to train these large language models. And when you really look at what's inside these models, it's a neural network with billions of parameters. And sometimes now we're moving into the trillions in terms of scale. But since these are general purpose sort of large language models, since they're trained on a huge chunk of the internet, which has all types of data, they really have a lot of versatility in terms of the task they can provide. So you could ask it to write a story, or you could ask it for a recipe, you could ask it to generate code, you could ask it to plan your vacation, or you could ask it to summarize data or do translations. So modern LLMs can do a lot of different tasks without any sort of specific training, just because based on the data that they've seen, they can actually produce fairly reasonable output based on the training that they had. In terms of some of the capabilities, now these days we are starting to see things like reasoning that are getting added. We also see previously large language models were primarily cutoff date. And now they can actually do some searches, get data real time from the internet and augment, even if they do have a cutoff, they can augment the responses that they provide. Another key to understand when it comes to LLMs is they do have a fixed context, which means they can only remember your conversation to a certain point, after which the context, it's like a rolling window in terms of the context where it rolls off. And that's when you can start seeing responses deteriorate. So something which we've talked more about in terms of what the context for LLMs really is. So in terms of actually building these LLMs, there is a process known as pre-training. So large language models what they're really good at is at the next token prediction. And you can think of token as either a character or it could be a portion of a word, which basically ends up being a token. And the reason why large language models use tokens is because even though they're language models, they don't really understand text. And computers, really don't understand text, but computers are great notes. And this is where tokens come in, where for example, if I were to take the English language as an example, English has something like 600,000 words in the English dictionary. And the way these tokens work is each word is assigned a number. And you can think of this as very fundamental, where each word is assigned a number. And when these large language models are trained, when they're fed these chunks of the internet, they start seeing patterns. They start learning patterns from these massive training data sets. And that's how they get good at predicting the next token based on what they've seen before. You can also do fine-tuning with the LLMs. And what this really does is it helps these large language models adapt to specific tasks. Or if you want to give your large language model a specific personality, or if you want to make it aware of a certain domain, whether that's healthcare or financial services or manufacturing or whatever industry-specific knowledge that it needs, you can actually train these LLMs using that data. And really the intent is, when you look at what the work that's being done in the industry is, I know they're trying to have these models be helpful, like an assistant where they will help you with whatever task or questions you have.
and then try to provide you the best answer that they can. So when we really crack open an LLM and see fundamentally what's in it, there's really two files that make up an LLM. And I'm oversimplifying this. So you really have a parameter file, which you see here in the diagram on the right. And the parameter file basically is where the parameters for the neural network are actually defined. So these are the weights that are defined for the neural network. And then you really have a small runtime. So this is a program that basically runs. And when you look at any of the popular companies like OpenAI or Anthropic or Google, what they really do is they put an API in front of this runtime and basically, expose that API where you can query and ask questions and get answers by querying the runtime, which then talks to the parameter file. So how do you really get the parameter file? And the way you get this parameter file is through the process called pre-training, which I mentioned earlier. And this really involves taking a huge chunk of the internet and really running it through this pre-training process, which involves using large clusters of GPUs. And in some cases, these are running hundreds of thousands of GPUs. And this pre-training process can run for several weeks. Sometimes it can run for months, which really lets you build that base model, which this is a process which is very compute intensive, very expensive, which is why very few companies can afford to do something like this, where they actually build these foundational models to create these parameter files. So when you look at some of the core capabilities for LLMs, what do they really do good at? They're really good at generating text. So things like, whether it's creative writing, whether it's being able to generate code, whether you want to do some sort of translation. And then there's also the conversational aspect to it. So this is where the concept of an assistant model comes in. So when you have your pre-trained model, generally what happens is you have human beings who basically write up different sample conversations, and then they use that to train them out to build actually an assistant model. So if you look at ChatGPT or any of the mainstream models that you can converse with, they basically have some pre-training that's been created by human beings that's fed to these models, which make them that helpful assistant. Now, this LLM technology is evolving at a very rapid clip. It does have some limitations, and as we speak, some of these are being overcome. But I think the number one problem with almost every model out there is hallucinations. So since a lot of these models will do a prediction in terms of the next token, they're very probabilistic rather than deterministic. So when you look at most computer systems or even if you're if you do traditional development or traditional programming, most of our use cases end up being very deterministic, which means if you have a standard set of inputs, you're almost always going to see the same output because, a lot of traditional programming is deterministic. But when it comes to large language models, they are more probabilistic. So you might see different, based on how the data flows through the neural network and which layers and what weights are triggered and fired inside the network, they can sometimes give you different responses. So that sometimes leads to hallucinations where the model might make up something and which is just not true. A lot of the models still have knowledge cutoffs, but the way they've offset this behavior is, they run, when you run a query to the model, in a lot of the modern models, whether that's ChatGPT or Claude, they can actually do a web search and try to pull some latest information. And even when it comes to some type of computational reasoning, there's some, famous, popular posts on social media, how many R's are there in a strawberry? And, you'll see sometimes they get it wrong. They are getting better now. I remember another one I remember seeing on LinkedIn where if you would ask Google, is it 2025? It would say, no, based on what I'm looking at, it's not 2025. So they still struggle with some computational reasoning, but I think these will just get better over time. In terms of choices, there's really two broad choices you have as an architect or as a technical leader for you to make a decision in terms of what type of large language model to choose. So you primarily have the open source models. So when you look at models like, this is something which OpenAI recently released, the GPT open source, GPT OSS. You have Llama, you have Mistral. Mistral actually has both. They have an open source and a closed source model. And then you also have, the popular open source models from OpenAI, from Anthropic, which is the cloud series of models, and then Google has the Gemini. series of models. So there's pros and cons with each sort of option that you might pick with. With the open source models, what really makes a model open source is if you have an understanding of what the weights are in the model and what data was used to train the model, that's really what makes it open source. But the closed source models, they really don't share much information other than, giving an API endpoint and giving you documentation on how to use the API. As a consumer, you really don't know what the weights are, and you have no way to change the weights for these models. And then you don't really know what data they use to train the model. So that's really the big, difference between open and closed source. So open source does give you a lot more control. It does let you do a lot more customization to it. And when it comes to, the proprietary models, these are very heavily funded companies. So they have a lot of resources at their disposal. So they are, cranking out new features, new capabilities very rapidly. So that's one of the benefits you have if you go with the proprietary models. You can either, from a hosting standpoint, you could either host this yourself. So you could either run this, whether that's on-prem or even in the cloud, where you manage it yourself, or you could just use, like an API endpoint, and it becomes a fully managed service for you. From a cost perspective, generally the open source models, and you'll see based on your scale. So there is sort of, if you were to plot your usage, on a graph, you'll see depending on your company and your use case, when you hit a certain amount of usage, the proprietary models or the closed source models can get expensive over time as you start consuming more tokens. And we'll look at more, some of these decisions, how you would make in terms of selection and cost. But once you get into larger volumes, the proprietary models can get expensive. And that's where, the open source models, you'll have a fixed cost. And then, it doesn't matter if you're having 5 million requests a day or 1 million requests a day, it's probably going to cost you almost the same, other than your infrastructure costs. So that's something you just have to keep in mind as you make this choice. When it comes to size, you do have different sizes in terms of the number of parameters these models have. So you have really the smaller models, which anywhere from 1 to 7 billion parameters that they have within the neural network and the model. And then you have medium-sized models, which go up to 70 billion parameters. And then you have the large models as well, which go into, in some cases, hundreds of billions and even approaching trillions of parameters. One thing to remember is that the biggest is not necessarily the best. You really want to make that selection based on your use case and what works well for your use case, which we'll get into the details of it later in the presentation.
If you like this video, you will love what I have to say next.
The 14-week Agentic AI program at Interview Kickstart helps engineers build real career-ready skills. You'll work on 2 live projects with FAANG instructors and leave with portfolio work that actually makes a difference in hiring. Over 20,000 tech professionals have already trained with Interview Kickstart, with many moving into roles paying upwards of $300K. Want to learn more? Join the free upcoming webinar, ask questions, meet the instructors, and see if it's a fit. Not ready yet? No problem. Start with the Agentic AI building videos here on the YouTube channel. We recommend this one. Either way, the key is to just get started.